Hi all, very happy morning, happy afternoon, happy evening to every student who is watching this video. Now this series is a special series which I started to help CAT 2020 aspirants and other management exam aspirants. We will start a special series that is nothing but the mock CAT series. What is these mock CAT series? I have observed in the last few days that there are extremely less number of videos in YouTube channel, or probably the institutes generally what they do is they conduct a mock CAT paper and they give the solution in the PDF format. Through my 15 years experience, I am going to take out Quant and an LRDI section, where I will be taking one session of Quant paper, then probably another session of LRDI paper. This series I will continue till August end, so that each and every student will understand right how to attempt an mock CAT paper, how to develop a strategy and everything. So right now this is nothing but we are at mock CAT-1 Quant paper analysis. If those of you who want all these questions, right, please WhatsApp me at the end of the class. I will send you the PDF 80500678991. Kindly WhatsApp these numbers so that you will get the questions in the PDF format. Right now, before you begin the class, there are few expectations from each and every viewer. The first expectation is, before seeing the solution, kindly pause the video and solve it on your own. Solve the question on your own. Then you see the approach at which I am solving the question. And all the questions which I developed, I will be solving 34 questions. All these 34 questions are based upon the previous year CAT papers. Not the original questions of the CAT papers, but the questions which are created based upon a thorough understanding of the examination. 34 questions I will be solving it, right, purely based on CAT paper. And if any student is preparing for, are you the one who is preparing for CAT 2020 exam and XAT 2020 exam, this is a must-watch series for each one of you. So that you will understand how the examiner prepares the question, how you should attack the question. This is not a strategy session. This is a complete video solution for all the 34 questions of mock CAT-1. So what we'll do is, we will go with every week 4 mock CAT 34 questions video series, so that probably in the month of July end, by the end of the July end, you will have good number of about close to 16 mock CAT video solutions and everything. And the questions will be of CAT level. Right? In case if you are a student who are expecting some basic questions to come, very less basic questions will be there. As you know, the last year CAT was more of a logical paper rather than the formula paper, right? So all the questions will be of intermediate to advanced level. So what I will do is, I will take up a question, I will discuss the concept that is used in the question, then I will solve the question. So each and every class 34 questions, just I am setting the rhythm right. Mock CAT 1 session it is. Now the questions will be a combination of number system. The questions will not be only from number system or arithmetic. That will do it in a sectional test. So the questions will be from number system. Questions will be from arithmetic. Questions will be from algebra. Questions will be from geometry and mensuration. And the questions will be from modern mathematics. So all the questions will be from these 5 topics. We will take separate mock CAT Quant, right, and mock CAT LRDI separately. Number system, arithmetic, algebra, geometry and mensuration, modern maths, right? If you attend all the mock CAT lectures of mine, you will be understanding all the various models that came in the CAT paper, and you are extremely prepared, right, to attempt the mock CAT paper. Most of the students who attend the class, what is taught in class is different from what comes in the mock CAT paper. So the gap I want to eliminate it through these video lectures. I hope you are all ready. I hope you are all ready. I think straight away we will get into the question. Kindly sit in the class with a notebook and a pen. Kindly sit in the class with a notebook and a pen. WhatsApp the number which is there on the PPT to get the PDF. Now, first question, why 34 questions we are discussing in the class? Because quant section has 34 questions, mock CAT-1. Now first question, see here sir, read the question. First read the question. Number of persons who booked a ticket for a New Year's concert, it is a perfect square. There are some people, it seems, who are going for a New Year concert, and the number of people who booked the ticket, it is a perfect square. So it is a square. If 100 more persons book a ticket, if the number of people increases by 100, then the number of spectators would be perfect squares plus 1. So if 100 more people increases, so the audience count will be perfect square plus 1. This is the first thing. If still 100 more persons, so already the number of persons who booked the ticket are perfect square, 100 added. If still 100 more persons book a ticket, then the number of spectators will be a perfect square. These are two equations. A square plus 100 is p square plus 1. A square plus 200 is b square. So a square plus 200, it is nothing but b square. A square plus 200, it is nothing but b square. Now we will see a concept, then we will come back and solve this question. Concept. See here sir, this is something which good number of questions in the previous year CAT paper came. X square minus y square equivalent to k. X square minus y square equivalent to k. Xy are integral values. Xy are integral values, right? If xy are integral values, x will be even, y will be even, or x will be odd, y will be odd, or x will be even, y will be odd, or x will be odd or y will be even. These are the four cases in integers. Integers could be an even integers, integers could be an odd integers. So these are nothing but x plus y into x minus y equivalent to k. Even plus even, it is nothing but an even number. Even minus even, it is nothing but an even number. Two even numbers are multiplied. Any even number is of the form 2k1. 2k1 into 2k2. It is divisible by 4. Odd plus odd is even, odd minus odd is also even. That means first two cases, if x is even, y is even, x is odd, y is odd, k is nothing but divisible by 4. K is nothing but divisible by 4. X is odd, y is odd plus odd even, odd minus odd even. X is even, y is odd, even square minus odd square, even minus odd is odd. If x is odd, y is even, odd square minus even square, these are nothing but an odd number. That means x square minus y square equivalent to k, x square minus y square equivalent to k. This equation has integral solutions only if right hand side is a multiple of 4 or right hand side is an odd number. Right hand side is an odd number. Right, first we will write down that point. X square minus y square equivalent to k has integral solutions, only if k is divisible by 4 or k is an odd number. This is the first important conclusion. When the k will be divisible by 4? When k will be divisible by 4? When x plus y is an even number and x minus y is an even number. When x plus y will be even, when x is even, y is even. When x plus y will be even, when x is odd, y is odd. K is an odd number. Odd number means x is odd, y is even. or x is even, y is odd. I hope this case is clear. Very, very important concept. Based upon this, some years before there was another CAT question. So what I did is, I took a CAT question, I wrote it down in my board, and I developed questions which may come in your examination. Do not leave any session of these mock CAT series. So what is that first statement? A square plus 100 is nothing but b square plus 1. Next one, 100 more are added. A square plus 100 plus 100 is b square. So b square minus a square, which is nothing but 200. This is nothing but b plus a into b minus a. It is nothing but 200. I hope it is clear. Now 200 is a multiple of 4. 200 is a multiple of 4. Now 200, if you see, 200, b plus a and b are integers. That means b plus a should be greater than b minus a. B plus a should be greater than b minus a. Now see, how can you factorize? It is 200 into 1. These is nothing but 100 into 2. These is nothing but 50 into 4. These is nothing but 25 into 8. 25 into 8. These is nothing but 20 into 10. 200 is nothing but 200 is 2 into 100, which is 2 square into 5 square, which is 2 cube into 5 square. So 4 into 3, total 12 factors I should get. 2, 4, 6, 8, 10. That means one more factor it is missing. 5 into 40. 40 into 5. 40 into 5. I hope it is clear. B plus a should be greater than b minus a. Why? Because a and b are integers. Now, this is 200 is divisible by 4. That means b plus a should be even. B minus a should be even. This case not possible. So, both should be even. This case not possible. This case not possible. Now, if I take b plus a as 100, b plus a as 100, and b minus a as 2. That means adding 2b equivalent to 102. B is nothing but 51. If b is nothing but 51, a is nothing but 49. A is nothing but 49. What is the first condition? A square plus 100 is nothing but perfect square plus 1. P square is 49 square. 2401 plus 100. Minus 1 is nothing but p square. 2500 is a perfect square. Definitely this is satisfying. This is satisfying. 100 into 2 is satisfying the question. Now even if you check 50 into 4, b plus a 50, b minus a 4, 2b is 54, b is 27, b is 27. So a is nothing but 20. B minus a is 4. So b is 23. 23 square plus 100. 529 plus 100. 629 minus 1. 628 is not a perfect square. Like that you can eliminate the cases. So how many people have booked the ticket? A is the number of people who booked the ticket. 49 people have booked the ticket. Very easy question. Very number system based question. Number system based question. Only thing, students get intimidated because of the length of the question that is there. Nothing is there. The number of people who book the ticket is right, is a perfect square, so it is a square. 100 more are added, it will become 1 plus perfect square. If 100 more are added, it is a perfect square. If you do not know this concept, here you will go for the enumeration. You will do for 100 into 2, you will do for 200 into 1. You can eliminate 1, 2, 3, 4, 5. 5 calculations if you can eliminate it if you know this concept. What is the concept that is used in this question? X square minus y square equivalent to k. This equation has integral solutions only if the right hand side is divisible by 4 and the right hand side is an odd number. Question number 1, I hope it is clear along with the concept. The reason why I am stressing upon the concept is the king. Once you learn all the concepts through these 34 questions, then your confidence of looking at a question will increase. I hope the idea it is clear, right? So these x square minus y square, one sample question. The best thing about experience is I can create questions on the spot and I can help you to understand the concept very clearly. This was the original CAT question, 9876543210. X and y are natural numbers. How many values x comma y can take? How many values x comma y can take? Just now we discussed x square minus y square equivalent to k, x square minus y square equivalent to k. These equation has integral solutions only if right hand side k, it is divisible by 4 and k is nothing but an odd number. So it should be divisible by 4. 10 is 4 into 2 plus 2. It is not divisible by 4. So answer is no value of x comma y. No value of x comma y exists. Many of the students, when they attempted this CAT paper some 4 years before, many websites, many social platforms also said that this question is a very difficult question because of enumeration. No beta, it is a very easy 5 seconds question if you know this concept. X square minus y square equivalent to k. This equation has integral solutions only if k is divisible by 4 and k is an odd number. Question number 1, concept, approach and an example. I hope it is clear. Question number 2. Another question, this question is neither the unit digit nor the counting problem. It is a combination of all the problems. If the last digit of the product, so 1 into 2, 1 into 2 is nothing but 2. 2 into 3, last digit only we require, which is the unit digit. 3 into 4 is nothing but 12, which is nothing but 2. 4 into 5 is nothing but 20, 20 unit digit is 0. 5 into 6 is nothing but 30, 30 again 0. Now let me write here so that you will understand the pattern. 6 sevens are 42, 7 eights are 56, 8 nines are 72, 9 tens are 90 unit digit, 10 11s are 110 again 0. That means if you observe 26200, 26200, these unit digits are getting repeated. How many cycles it is becoming? So the cyclicity is 5. The cyclicity, it is nothing but 1 plus cyclicity is for every groups of 5 consecutive, the value it is nothing but 5. So what is the sum of this? Sum of these is nothing but 2 plus 6 8, 8 plus 2 10. That means every group of 5 consecutive integers is giving you sum 10. Every group it is giving you sum 10. The total sum of the unit digit is 2010. Every group of 5 it is giving you 10. Like that 201 groups. 201 groups. 201 into 10 is nothing but 2010. First group, fifth, it is ending with 5 into 1. Second group it is 5 into 2. 201th group it is 1005 into 1006. Next it is 1004 into 1005. Next it is 1003 into 1004. Next it is 1002 into 1003. Next it is 1001 into 1002. I hope it is clear. So this is the first group, second group. Total 201 groups are there. Total 201 groups are there. Each group sum is 10. Each sum of the group is nothing but 10. Total 201 into 10 is 2010. I hope it is clear. These again nothing but 2. These nothing but 6. These nothing but 2. These 0. These 0. These one question where most of the students will do a silly mistake. Knowingly or unknowingly. This process you can do it. So immediately you will tick mark the answer as how many products are used. You will tick mark the option as 1005 because till 1005 you got sum as 2010. But see here, wantedly I kept this question because I wanted to tell you, right, this sum is 0. That means till here also the sum is 2010. 2010 plus 0, it is 2010. Plus 0, it is also 2010. So how many products are used? Till here it can be used. 1003 groups can be used. These unit digit is 0, so these also can be used. So answer is not 1005. How many products are used? Not 1005 products. It could be 1003 products and 1004 products, because 1005th product is 1005 into 1006. Unit digit is 0. 2010 plus 0 is nothing but 0. These also nothing but 0. So you can take till here, or you can take till here, or you can take till here. 99.99% of the students in hurry, impatient students will tick mark 1005, and they will tell their friend that this question is an easy question and I got 1005. There is another option 1003. There is an option 1003, 1004 and 1005. Be extremely careful. Be extremely careful while solving counting related problems. Extremely careful. Read the question twice. Read the question twice so that you will get an idea. I hope the idea it is clear. How many products are used? 1003, 1004 and 1005. Second question, I hope it is clear. Third one. Beautiful question, sir. These probably the, what is the remainder when 2 power 32 is divided by 641? Before seeing the solution, pause the video and try to solve it. Negative remainder. If you use a negative remainder, it will be very time consuming. If 641 is a prime number or a composite number, if you use any theorems, these also will be time consuming. These also will be time consuming, right? This is the doubt asked by a student 2 years before. Sir, can you please tell me, right? 2 power n plus 1, right? These prime or composite. If it is composite, why it is 2 power 32 plus 1 is composite? This was the doubt asked by a student some years before. So I developed a question for this. Neither the negative remainder nor any of the theorems will solve this question very fast. Now see, how am I going to solve this question? What is the remainder when 2 power 32 is divided by 641? 641. There is a speciality with respect to 641. These are nothing but 640 plus 1. These are nothing but 5 into 128 plus 1. These are nothing but 5 into 2 power 7 plus 1. 128 into 5 is 640 plus 1. Now see here. Remainder when 640 divided by 641. 641 ones are 641. It is minus 1. These are nothing but 5 into 2 power 7 divided by 641. These are nothing but minus 1. Do power 4 on both the sides. So this will become 5 power 4 into 2 power 28 divided by 641. Minus 1 power 4 is nothing but 1. 5 power 4 is 625. 625 divided by 641 is minus 16. So minus 2 power 4 into 2 power 28 divided by 641. It is nothing but 1. These nothing but a remainder of 2 power 32 divided by 641. Minus multiplication. It is minus 1. Minus 1 means positive remainder will be 640. Positive remainder will be 640. I hope the idea it is clear. 641 it is nothing but 5 into 128 plus 1. So 640 divided by 641 is minus 1. 640 is 5 into 2 power 7. So I did power 4 both the sides. Power 4 both the sides. 5 power 4 into 2 power 28. 625 divided by 641 is minus 2 power 4. Minus if I multiply 2 power 32 by 641 is minus 1. So minus 1 is nothing but positive remainder 640. Probably one of the best questions in geometry reminders, sir. One of the best questions in reminders. One of the best questions in reminders, where if you understand how to write 641 as 5 into 128 plus 1, you will get the answer very easily. Question number 3. Question number 3 is on reminders. Question number 2 is on counting. Question number 1 is on algebraic integral solution. Question number 4. Question number 4. Now see here. First we will see the concept. First concept. How many integers may be the measure in the degree of the angle of a regular polygon? He is asking in the degree of the angle. Angle means interior angle. Interior angle in degrees, how many integral values it can take in a regular polygon? Polygon is nothing but n greater than or equivalent to 3. N is nothing but the number of sides. Polygon is nothing but an n-sided closed figure, n greater than or equivalent to 3. First point. Next point. Sum of all interior angles. Sum of all interior angles. Sum of all interior angles in a convex polygon. Sum of all interior angles in convex polygon of n sides. It is given by n minus 2 into 180 degrees. N minus 2 into 180 degrees. Why it is n minus 2 into 180 degrees? If there is a four-sided closed figure. If there is a four-sided closed figure, take any point, join the non-adjacent. How many triangles I got? 2 triangles I got. If it is a 5-sided figure, take a point, join the non-adjacent. How many triangles I got? 3 triangles I got. So, if I take a 4-sided figure, I got 2 triangles. If I take a 5-sided figure, I got 3 triangles. If I take an n-sided figure, I will get n minus 2 triangle. Triangle is nothing but, sum of the 3 angles in a triangle is nothing but 180. So, sum of all interior angles in a convex polygon is n minus 2 into 180 degrees. Each interior angle, for n sides it is n minus 2 into 180. Each interior angle it is n minus 2 into 180 by n. These nothing but 180n minus 360 by n. These nothing but 180 minus 360 by n. This is a question based on geometry. Each interior angle is given by 180 minus 360 by n. See here, sir. Each interior angle is nothing but 180 minus 360 by n. What is specified in the question? Interior angle should be an integer. Interior angle should be an integer. This should be an integer. 180 is an integer. 360 by n should be an integer. 360 by n is an integer. N should be a factor of 360. 360 is nothing but 2 cube into 3 square into 5 power 1. So it is nothing but 4 into 3 into 2. So most of the students may tick mark 24 as the answer, but 24 is not the answer. Right? Why? Because polygon means n is greater than or equivalent to 3. So in that 24, n equivalent to 1 and n equivalent to 2, both should be eliminated. So how many integral values n will take? Right? What is how many integral values interior angle can take such that this equation is satisfied? For an interior angle to be an integer, n should be a factor of 360. I got 24 values. N value 1 and n value 2 both are eliminated. Why? Because a closed figure n greater than or equivalent to 3, it is a polygon. So fourth question is based on geometry. I hope the idea it is clear. Next one. Oh, this is a beautiful question, sir. The most repeated concept from number system. Fifth one. Several sets of prime numbers such as 783, 421, 659. Use each of the 9 non-zero digits exactly once. What are the non-zero digits? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 non-zero digits. Now some numbers are formed from the combination of these digits such that each one is a prime number. 7 is a prime number, all are prime numbers. What is the smallest possible sum? such a set of prime numbers can have smallest set, that means in the set some elements are there, elements sum should be minimum, elements sum should be minimum means I should start with a prime numbers which are single digits, then I should go to a 2-digit number. I will not take larger prime numbers because entire sum should be an minimum number. So minimum number 1 is not prime, right? Now first I will take 2, 3 and 5 because every number should be an element in the set should be a prime number. 2, 3 and 5 I have taken. 2, 3 and 5 I have taken. Next I have to form prime numbers. Suppose 1 is there, 4 is there, 41, it is a prime number. These both are out exactly once. Next one, 67 is there, prime number. 89 is there, it is a prime number. Are you all with me? So all the digits are used. 1, 2, 3, 4, 5, 6, 7, 8, 9. All the digits are used. 2, 3, 5. I cannot take single digit 4, 6, 8 or 9. Can I take single digit 7? That also we will take the case. If these 4 and 6 are interchanged. 2, 3, 5, 61, 47, 89. Still 61 is a prime number, 47 is also a prime number. Sir, because I am taking every element as a prime number, every element in the set as a prime number, and the sum should be minimum, and the sum should be minimum. That means it should start with a single digit prime numbers. It should start with a single digit prime numbers. So in single digit prime numbers, we have taken 2, 3, 5. Let us take 7 also. So we will remove 5 and we will keep it 7. So 2, 3, 7. If I take 2, 3, 7, what are the other numbers? 1, 4, 1, 2, 3, 5, 6, 7, 8, 9. 1, 4, 5, 6, 7, 8, 9. Now let us see which case is possible. 1, 2, 3. Now if you see here, is this also possible? Now 1, 2, 3. 1, 2, 3, 7, right? 7 also is taken. Now what is the other case that is possible? 61 is a prime number. 61 it is a prime number. Next one, what is the other case? 98, it is not possible. So what we'll do is 1, 2, 3. 1, 2, 3. Let me take 53 here. 53 is a prime number. 2, 53 and 7. Next it is 2 over, 3 over, 5 over, 7 over. 1, 4, 6, 8, 9. In 1, 4, 6, 8, 9, what are the cases that are possible? 1, 4, 6, 8, 9. 46 it is a composite number. 48 it is a composite number. 49 it is a composite number. 60, 67 this is possible. Next one. So 63, next it is 41, next it is 89. Is this another set that is possible? Everything I have taken 1, 2, 3, 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. Let me check if any other case is possible. 2, 5, 7. If I take single digit prime numbers, 2, 5, 7. 2 is taken out, 5 is taken out, 7 is taken out. Can I write it as? I will write down here 2, 5, 7. I hope you are understanding little bit of counting it is there. But anyway, smallest it is asking. Let me write one more case. So 2 is taken. 5 is taken, that means 1 is left, 3 is left, 4 is left, 6 is left, 8 is left, 9 is left, 9 is left. Now we have to get prime numbers. If we have to get prime numbers, 89 is another case, it is possible. 61 is another case, 43 is another case, 43, 61 and 89. 43, 61 and 89. Like that, so many cases we are getting. Smallest we need to find out. Smallest, if you see here, 2 anyway will come, 3 anyway will come, 5 anyway will come. 41 is less than 43, right? 2, 5, 7, right? Just check this sum. These is nothing but 10. These is nothing but 140, 180. These is nothing but 70. This is 207. Let us check this value. This is nothing but 10. This is nothing but 100, 180. Again it is coming out to be 207. If I take this one, 7 plus 7, 14. 14 plus 180 plus 13. 180 plus 13. These again nothing but 207. So answer is nothing but the smallest set of, right, sum of such of set of primes is nothing but 207. I hope the idea it is clear. Very good question, right? There is no particular theorem on prime numbers this question. Watchfully, carefully, slowly you have to find it out. Only thing what you have to be good is in picking out that number such that it is a prime number. Anyway, smallest, right, this case is eliminated. Question number 5, which is nothing but little bit of enumeration question. Probably 95% of the questions which I take in these mock CAT series, you will not find in any of the regular textbooks. Even if you find it, I will twist that question. I spend a lot of time in doing a research. If you watch any video of mine in my YouTube channel, you will realize the way I teach. Right, 5th one, I hope it is clear. Next one, the most highly repeated mistake question. Please read the question. How many ordered triplets? Ordering also matters. Ordering also matters means 1 into 2 into 3 is different from 3 into 1 into 2. It is different from 2 into 3 into 1. A comma B and B comma A both are unequal. That is what do you mean by ordered triplets? ABC of non-zero real numbers. All ABC takes non-zero numbers. Each number is the product of other two. There are 3 non-zero real numbers. Each number is the product of other two. Each number is the product of other two. So if I multiply ABC equivalent to ABC whole square. So immediately students will tell 1, 1, 1, it is the case. These what the mistake, and that is exactly what I wanted to teach you through this problem. So it is nothing but ABC into ABC minus 1 is 0. ABC cannot be 0. It is given that it is non-zero. So ABC equivalent to 1. ABC 1 is 1 into 1 into 1 is 1. But it is minus 1 into minus 1 into 1. This is also 1. Yes or no? It is not given that it should be positive numbers. It can be negative. And it is given that it is an ordered pair. These 1, 1, 1, there is one way. These 3 numbers can be arranged in 3 factorial. Minus 1, 2 times it is 3 ways. What is that 3 way? First 2 can be negative. Second 2 can be negative. First and third can be negative. Are you all with me? So 3 plus 1. Answer for this question is 4. Answer for this question is nothing but 4. I hope the idea it is clear. Most commonly done silly mistake, it is only because you have not read the question properly. It has nothing to do whether you know it or not it. These are the questions which actually make you throw away from 98 percentile to 95 percentile because of little impatience. Immediately you will read that each number is the product of other two. 1, 1, 1 will satisfy, you will tick mark. What you are not forgetting it is only said that it is a non-zero real number. It is not said that all the numbers are positive real number. So minus 1, 1. I hope you are all enjoying these, right? Questions where you may do mistakes. Questions where you need to learn a concept to make that toughest of the question very, very easy. If you are enjoying these questions, if you love quality solving questions, go and click the like button. And if you are a first time user, kindly subscribe to the channel. You are someone who is preparing for CAT. Your friends are also preparing for CAT. Please tell them that there is a special mock CAT video series that I am running it, and it is absolutely free for the month of July. Any CAT aspirant all over India can watch these videos. I hope you enjoyed these logic problems, because I enjoyed a lot while creating it. I am sure you will also enjoy a lot while solving it. Sixth one, seventh one. Another question, right? Another question. Please read the question. Rajat decided to tell the truth. There is a person by name Rajat. He tells the truth only on 3 days a week. Monday, Thursday and Saturday. And he lies on every other day. That means this is the question based on truth and lies. Right? A logical reasoning kinda question in quant section. Right? He tells the truth. He tells the truth on Monday, Thursday and Saturday. Right? And he tells the lie on Tuesday, Wednesday, Friday and Sunday. Okay, question clear? One day he says, I will tell the truth tomorrow. Now listen carefully. Assume I am Rajat. I made a statement to a viewer, right? I will tell the truth tomorrow, right? Assume that today is Monday. If I made this statement on Monday, what does that mean? Monday he will be truthful. I am Rajat, I am truthful. That means today I made a true statement. I will tell the truth tomorrow. Tomorrow I will say the truth. That is the statement. Tomorrow is Tuesday. Tuesday, if the statement is announced on Monday, that means Tuesday also he will tell the truth. But according to the question, Tuesday he has to lie. But according to my assumption that he tells this statement on Monday, Tuesday he will tell true. So that means Monday cannot be the day. If it is Tuesday, assume today is Tuesday. I will tell the truth tomorrow. Tuesday anyway he will lie. That means today I lied. I will tell the truth tomorrow. Tomorrow also I will not tell the truth. That means today it is a lie and tomorrow also it is a lie. Today it is a lie, tomorrow also it is a lie. 2 consecutive days are lies if the starting day is Tuesday, which is possible. I hope. So which day he made the statement? He made the statement on Tuesday, which is a lie. Tuesday he made the statement which is a lie. I will tell the truth tomorrow, it is a lie, because tomorrow is Wednesday. Wednesday he will lie. I hope it is clear. A very, very good reasoning question. Just if you read the question and think logically, you will get the answer. 7th question. I hope it is clear. Next one. While adding, these again taken from an previous year CAT question. While adding all the page numbers of a book starting from 1, 2, 3 and so on up to n. He is adding all the page numbers. 1 plus 2 till n is n into n plus 1 by 2. He realized that, right? He realized that. Now we will see here. 2 cases we will see. We will remove 1000 and put 575. Right? Then I will tell you another question with 1000. There is one page number he has not counted. He forgot to count. These page number could be any page number from 1 to n. I hope it is clear. First we will do it with 575. Is this equation clear? I am counting every page number. One page number I forgot to count. So it is minus x. Now n into n plus 1 by 2. It is nearer to 575. I will tell you why I did this. N plus 1 is closer to n. N square is nearer to 1150. What is the perfect square just greater than 1150? 34 square is 1156. 34 square is 1156. Why approximated became equal? There cannot be a value less than 34. There cannot be a value greater than 34. I will tell you why. First, let me substitute 34. So 34 into 35 by 2 minus x is nothing but 575. 595 minus 575, it is nothing but x. The number which he forgot to add, it is nothing but 20. So answer is, how many page numbers are there? 34. Which number he forgot to add? 575 is he forgot to add 1000 is for double counting. 2 questions I will solve. Right? 1, 2, 3 and so on up to n. n into n plus 1 by 2. He forgot to add one page number x. So 34 into 35 by 2. I just took a perfect square just greater than 1150. N is 34. Less than 34 not possible. Greater than 34 not possible. Now why it is not possible? Suppose see here. These is nothing but n into n plus these 575 and he forgot to add. It is forgot to add. So n into n plus 1 by 2 minus x is nothing but 575. I said n equivalent to 34 is the only case possible. N less than 34, n greater than 34, both the cases are not possible. Why we will see. If I take 35, 35 into 36 by 2, these is nothing but 630. 630 minus x is nothing but 575. X value is 55. I am telling that the page numbers are 35, but you are telling that the number which we forgot to add is 55. Right? It is illogical. So it is not possible. N equivalent to 33. 33 into 34 by 2, which is 17, which is 17, 3s are 51, 561. 561 minus x is 575. On 561, if you remove a positive value, you will get 575 it seems. That is also illogical. N less than 34 not possible. N greater than 34 not possible. The only value that is possible is 34. Question is like this. The sum is 575 if I forgot to add one page number. What if I add one page number? What if I add one page number? Now see here. Suppose have been counted twice. Next one. Have been counted twice. So if it is have been counted twice, one page number is counted twice. It is actually n into n plus 1 by 2. One page number it is counted twice plus x. The page number which is counted twice should be from 1 to n. So these is nothing but n into n plus 1 by 2 nearer to 1000. N plus 1 is nearer. N square is nearer to 2000. To this expression I am adding something. So I should take a perfect square just less than 2000. 44 square is 1936. So these is nothing but 44 into 45 by 2 plus x. It is nothing but 1000. This is 990 plus x is nothing but 1000. Number which I forgot, which I added twice is nothing but 10. I hope it is clear. Number which I added twice is nothing but 10. I hope it is clear. So two questions which I discussed. One is sum is 575. Sum is 575. Forgot to add one number. Sum is 575. Forgot to add one number. Sum is 1000. Added one number twice. Added twice. Two cases. I hope it is clear. Two cases. I hope it is clear. So number which is page number which is added twice is 10 and the number of page numbers are 44. These is taken from an original previous year CAT questions. All the questions which I discuss in these mock CAT series are nothing but the taken heavily from the understanding the patterns of the CAT paper. I hope it is clear. I hope Manish it is clear to you. Right? Two questions are there. 575 forgot to add one number. 1000 number added twice. Two models which we discussed. Whenever I think that I need to discuss, write some more questions, I discuss. Kindly reply it in the live chat. Kindly reply it in the live chat if this idea it is clear. Idea it is clear, right? Another question. Another question, right? If you solve with me 15 mock CATs, you will understand the flow chart, you will understand the variety of questions. The first thing which I will kill you is the fear you got in attempting the mock CAT papers. That is my entire agenda in the month of July. Of course, for the enrolled students, there are lot of videos which I am recording it and I will upload it into their portal. Next one, another question. How many positive integers? We do not know whether it is a single digit, 2 digits, 3 digits, 4 digits, right? Which is equivalent to 12 times the sum of their digits. If I take a single digit, A is 12 times A is a single digit, so it cannot take a 2 digit value. Single digit, it is not possible. Suppose if I take 2 digits, AB, A is there in tens place, so it is 12 into A plus B, 12 into A plus B, so this will become 10A plus B equivalent to 12A plus 12B. These are nothing but 2A plus 11B equivalent to 0, 2A equivalent to minus 11B. A by B is, one is negative, another is positive. This case also it is not possible. Digits means always positive value it will take if it is, the number is a positive number. Single digit it is not possible, 2 digits it is not possible. Let me take a 3 digit number which is ABC. 3 digit number is ABC, right? So these are nothing but, these number it seems it is 12 times the sum of their digits, 12 into A plus B plus C. A is there in hundreds place, B is there in tens place, 10B plus C equivalent to 12 into A plus B plus C. 100A minus 12A is 88A, 12B minus 10B is 2B, 12C minus C is 11C. This is divisible by 11. This is divisible by 11. B is a single digit, so 0 will make it divisible by 11. 11 zeros are 0. So these nothing but 88A equivalent to 11C, C equivalent to 8A. That means if A is 1, C is 8. So the number is nothing but 108. 108 is nothing but 12 times the sum of their digits. Sum of their digits is 1 plus 8, 9. 12 nines are, it is 108. So in a 3 digit number, I got one number that is 108. Here B is a digit. B cannot take 11 beta. B is a digit. A digit can take any value from 0 to 9 only. So beyond 0, no other case possible. Then what will happen if it is beyond 3 digit number? If it is beyond 3 digit number, what will happen? Let us see. 3 digit number, I hope it is clear. If it is a 4 digit number, it could be any, he said how many positive integers. So it is A, B, C, D. A is there in thousands place, B is there in hundreds place, C is there in tens place, plus D. It is 12 times the sum of their digits. 1000A minus 12A, which is nothing but 988A, plus 100B minus 12B, 88B. These is nothing but 12C minus 10C, it is 2C. 12D minus D, which is nothing but 11D. A, B, C, D. Here A is there in the leftmost. Leftmost means A will take any value from 1 to 9. D and C, they are all integers. Maximum value D and C can take is 9. So these 99 plus 18, which is 117. Here the minimum value A will take is 1. Here I am getting minimum value as 988 plus something. Here I am getting maximum value as 117, which is 11 into 9 plus 2 into 9. So 4 digit number onwards, it is not possible. The only positive integer which will satisfy this question is a 3 digit number, which is nothing but 108. 108 is nothing but 12 into 9. I hope the idea it is clear. Idea clear, right? 4 digit number. A lot of good quality questions which we will take in our class. Next one. Find all the prime numbers P how many prime numbers are there for p such that 5p plus 1 is a perfect square. Any perfect square is nothing but of the form x square. I will write it as x plus 1 square, because here if x is, this can be x and x plus 1 could be any number. So if x square is 4, this will be 2. Here x value will be 1. That's all. The value of x decreases by 1. Why am I doing it? I will tell you. Right? So find all the prime numbers values for p such that this number is a perfect square. I will call perfect square as x plus 1 whole square. This is nothing but 5p plus 1 equivalent to x square plus 2x plus 1. These 1 will get cancelled. 5p it is nothing but x into x plus 2. X into x plus 2. Now see here, sir. X into x plus 2. This is nothing but a multiple of 5. That means here it should be a multiple of 5. Are you all with me? So if x is 5, x plus 2 it will be 7. So 5p it is nothing but 5 into 7. So p value it is nothing but 7. P value it is nothing but 7. Or if x plus 2 is 5, this is nothing but 3. So 5p it is nothing but 3 into 5. P value it is nothing but 3. P value it is nothing but 3. Now why did I write it as x plus 1 whole square is because it is 5p. Anyway right hand side 5. Here I got difference 2. Is there any prime number which is having a difference of 2 with 5? 3 and 7. Directly I can go ahead and I can do it. You can also do it with x square, but that will result in x minus 1 into x plus 1. X minus 1 into x plus 1. There is a prime triplet. There is a prime triplet which has a deviation of 2. There is a prime triplet which has a deviation of 2. Suppose see here 5, 7, 11. There is no deviation of 2. 7, 11. Right 13, there is no deviation of 2. 23, 29, right, next it is 31. There is no deviation of 2. I wanted to tell you that even in a prime number series, the triplet which has a deviation of 2, it is nothing but 3, 5 and 7. So p value will be 3, p value will be 7. P value will be 7. I hope it is clear. Now you might get a doubt. Sir, can I take p value 5? 25 equivalent to x into x plus 2. There is no product of 2 numbers with a deviation of 2. It will give 25 because the factors of 25 are 1 into 25 and 5 into 5. Why I am telling? What if this is a prime number which is 5? This case is not possible. I hope this idea it is also clear. I hope this idea it is also clear. Next one. Beautiful question, sir. Right? A lot of good questions which you will solve. Take some time to digest this. Another beautiful question based on HCF. Another beautiful question based on HCF. First we will see the concept. Now see here. Concept. Now if you see here, these nothing but HCF of 33333 2010 3 times, comma 77777 2005 sevens, 2005 sevens. These nothing but HCF of 3 into 111111 2010 ones. These nothing but 7 into 111111 2005 ones. Here it is 2010 ones. These nothing but HCF of 3 by 9 into, can I write like this? 10 power 2010 minus 1. These nothing but 7 by 9 into 10 power 2005 minus 1. Why? Because if 1 is written 2 times, it is 10 square minus 1 by 9. 99 by 9. If 1 is written 2010 times. I hope this idea it is clear right till here. Now see here. Now 10 power 2000. What is HCF of this numerator by denominator? HCF HCF of numerator by LCM of denominator. HCF it is nothing but 10 power 2005 minus 1. HCF means what is the power common in both of them? 2005. These is nothing but 9. These is nothing but 9. I hope it is clear, right? These is nothing but 9. So these is nothing but, most of the students will write it as 5 sevens, 5 ones it is the answer. I hope it is clear. 5 ones it is the answer. Is it clear? 5 ones they will do it as think. But there is a small catch in the question that also will. This is an incorrect answer. 5 ones it is an incorrect answer. 5 ones it is an incorrect answer. Then what is the right answer? 3 into 111 2010, 7 into 111 2005, to 10 power 2010 minus 1 by 9, to 10 power 2005 minus 1 by 9. HCF of numerator by HCF of denominator, right? LCM of denominator. LCM it is nothing but 9. So they will say that the answer is 5 ones. 5 ones anyway it will be a factor. But one observation, see here. Always see here, sir. If a non-zero digit is written in groups of 6, it is always divisible by 7. Why? Because remainder of 10 cube divided by 7 is 7 ones are 7, 3 cube is 27, 7 fours are 28 minus 1. So these nothing but 333 divided by 7 if I take, these nothing but 333 into 10 cube plus 333 divided by 7. 10 cube by 7 is minus 1. Minus 333 plus 333, it is 0. Please write down this important point. Any single non-zero digit written in groups of 3, it is always divisible by 7. First key point. Second key point, any 3-digit number written even number of times is always divisible by 7. Make a note of these two important key points. 10 cube by 7 is minus 1. So 333 into 10 cube plus 333. These minus 333 plus 333. Any 3-digit number written even number of times is always divisible by 7. Always divisible by 7. Now see here. What the small catch in this question is, if you see 333 plus minus, that means it is divisible by 7. Are you with me? So if 3 is written in groups of 6, it is divisible by 7. 2010 is nothing but 6 3s are 18, 21, 335 groups. Perfectly, it is written in groups of 6. This is divisible by 7. Anyway, these also divisible by 7. 7 written any number of times, it is divisible by 7. So 7 is also a factor common. Another factor common which we got is 5 ones. So answer is nothing but, answer for this question is nothing but 5 sevens. This is divisible by 7. This is divisible by 7 because any single non-zero digit in groups of 6, it is always divisible by 7. Sir, can't I do for 3? Better see here. This is divisible by 3 because 333 and everything. 7 written 2005 times. What is the divisibility rule of 3? Sum of the digits should be divisible by 3. 7 sevens are 49. It is not divisible by 3. So therefore only 1 7 you will get. So answer is nothing but 7 into 5 ones. 7 into 5 ones, answer is nothing but 5 sevens. I hope the idea is clear. Please do not take the answer as 5 ones. 5 ones anyway it will come just by looking at is. These nothing but a 10 power 2010 minus 1. These nothing but a 10 power 2005 minus 1 by 9. It is into 7. It is into 3. HCF of these both is nothing but 5 ones. But 3 written 2010 times is divisible by 7. 7 written 2005 times is also divisible by 7. I hope it is clear. Very, very important problem. Silly mistakes, please avoid it. This is the beauty of the CAT examination. Write straightforward question, no. They will twist it to such a level that where you may do little more silly mistakes. I hope the idea it is clear. This question. Next one. Another question. Very, very good question. There are some numbers 1, 2, 3 till 2011. These numbers are given to some variables in an arbitrary way, A1, A2 till A2011. A2011. In these 1, 2, 3 till 2011, there are 1006 odd numbers. There are 1006 odd numbers. And there are 1005 even numbers. There are 1005 even numbers. This is the one observation. Now see, he said what is the remainder? What is the remainder when A1 minus 1, A2 minus 2 and so on up to A2011 minus 2011 is divided by 2. Is divided by 2. Let us see here 1 to 2011 total there are 2011 natural numbers, out of which 1006 odd numbers are there, 1005 even numbers are there. Let me take a smaller example, then I will explain it. A1, A2, A3, A4, A5. Let there are 5 numerical values 1, 2, 3, 4, 5 which are assigned to these values in an arbitrary way. 5, 1, 3, 4, 2. Suppose if I do A1 minus 1, A2 minus 2, A5 minus 5 and it is divided by 2. Now if you see here, 5 minus 1 is 4. 4 is an even number. Even into any number. Even into any number even. Even divided by 2 it is 0. So because there are 2011 numbers out of which 1006 odd numbers are there, there is a chance where odd minus odd I will get even, or I will get even minus even, it is also even, depending upon which number you are choosing, right? If you choose A1 as an odd number, 1 is an odd number, odd minus odd it is an even number. If you choose A2 as an even number, even minus even it is an even number. Even number into any number is even. When divided by 2, what will be the answer? 0. What will be the answer? 0. Suppose even if it is A1 minus 1, A2 minus 2, A1005 minus 1005. If you are giving all 1005 even numbers here, even minus even it is even. Even if you are giving odd numbers here, odd minus 1 is nothing but odd. Odd minus odd is nothing but even. Even into any number when divided by 2, remainder is nothing but 0. Remainder is nothing but 0. I hope the idea it is clear. Remainder is nothing but 0. Next one, answer for this question is 0. This is a very beautiful question, sir. How many sequences of, I have to use the sequence of 1 and 2 to get the sum 15. To get the sum 1, I will use 1. To get the sum 2, I will use 1 plus 1. Or I can use directly 2. I have to use only 1 and 2 to get the sum 15. To get the sum 3, I have to use only 1 and 2. 1 plus 2, 2 plus 1. Or I can do 1 plus 1 plus 1. Are you all with me? That means if you observe, there is only one way to get the sum 1, that is 1. There are 2 ways to get the sum 2. There are 3 ways to get the sum 3. This is nothing but a Fibonacci series. Fn equivalent to Fn minus 1 plus Fn minus 2, n greater than or equivalent to 3. So the first it is 1, second it is 2, next it is 3, next it is 5, next 8, next 13, 21, 34, 55, 18, 9, 144 and so on. These is nothing but sum 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Next it is nothing but 144 plus 18, 9, which is 233. Next it is nothing but these 12. I want some 15. Right? Next it is nothing but 377. next it is nothing but 600, next it is 977. These 13, 14 and 15. I hope the idea is clear. A beautiful question based on the application of a Fibonacci series. What is a Fibonacci series? Fn equivalent to Fn minus 1 plus Fn minus 2, n greater than or equivalent to 3. 2 can be written as 1 plus 1 and 2. 3 can be written as 1 plus 2, 2 plus 1 and 1 plus 1 plus 1. So 1, 2, 3. The current number is the sum of the previous two numbers. 5 plus 3, 8. 8 plus 5, 13 and it continues. Idea is clear, right? How many sequences of 1s and 2s will sum up to 15? Beautiful application of a Fibonacci series. Beautiful application of a Fibonacci series. Idea is clear? Next one. A coin is tossed 6 times. Suppose if I toss a coin 1 time, either I will head or tail. If I toss a coin 2 times, either I will get head tail, tail head and tail tail. I hope it is clear. No 2 consecutive heads. This should not come. That means this is 2 cases. These 3 cases. Suppose if it is 3 times HT. After these T can come. No 2 H will come. After T H can come. H cannot come. Only T can come. T. Right? H can come. T can come. 2H is not possible. So 2 plus 2, 4. 4 plus 1, 5. Again a beautiful application. One time it is 2 cases. 2 times 2 with no 2 consecutive heads. 3 times. 5. Next it is 8. Next 13. Next it is 21. So these is nothing but 1 time. These is nothing but 2 time, 3 times and so on up to. These is nothing but the 6th time. I hope the idea it is clear. Answer for this question is nothing but how many ways exist such that there are no 2 consecutive heads. Answer for this question is nothing but 21. Answer for this question is nothing but 21. I hope it is clear. Next one. Find the sum of all the remainders where remainder 1 n power 5 minus 5n cube plus 4n when divided by 120, what is the remainder? N is an integer greater than or equivalent to 2010. Suppose if I take n common, this is nothing but n power 4 minus 4 and 5n square plus 4 when divided by 120. These is nothing but remainder of these n square minus 4 into n square minus 1 when divided by 120. These is nothing but n square minus 4 is n minus 2 into n plus 2. N square minus 1 is n minus 1 into n plus 1. So these is nothing but n minus 2, n minus 1, n plus 1, n plus 2. These are nothing but 5 consecutive integers. 5 consecutive integers is always divisible by 120. If I take n value as right of 1, 1, 2, 3, 4, 5, these is nothing but 120. 5 consecutive positive integers because n is greater than or equivalent to 2010. So from n1 onwards, any 5 consecutive integers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you observe, all are divisible by 120. Answer for this question is 0. Answer is nothing but 0. Remainder 1, n power 5 minus 5n cube plus 4n. N common, n power 4 minus 5n square plus 4. These n square minus 4 into n square minus 1. N minus 2, n plus 2, n minus 1, n plus 1. These are nothing but 5 consecutive positive integers. 5 consecutive positive integers is always divisible by 120. Answer for this question is 0. Answer for this question is 0. I hope the idea it is clear. Another question. This is a question based on an algebra. This is the question based on algebra. X square plus ax plus b plus 2 equivalent to 0 has real roots. Real means discriminant greater than or equivalent to 0. Discriminant. What is the discriminant? In b square minus 4ac greater than or equivalent to 0 for a quadratic equation ax square plus bx plus c equivalent to 0. A square minus of 4 into b plus 2 greater than or equivalent to 0. A square minus 4b minus 8 greater than or equivalent to 0. A square greater than or equivalent to 4b plus 8. If I add b square, a square plus b square is b square plus 4b plus 8. These are nothing but a square plus b square greater than or equivalent to b plus 2 whole square, b square plus 4b plus 4 plus 4 plus 4. These a square function is greater than or equivalent to 0. So the minimum value is nothing but 4. Minimum value for these a square plus b square is nothing but 4. Easy question. Only thing is you have to add b square and try to make this term as a square. Very easy question. Minimum value is nothing but 4. I hope the idea it is clear. Next question. We will read the question. What is the smallest possible difference between a square number and a prime number? There is a square number. Right, there is a square number and a prime number. Difference minimum value he is asking. Difference minimum value he is asking. Square number is greater than prime. So x square is greater than p. X square is greater than p. Now if you see here, suppose x square is greater than p. Suppose if I take 2, what is the square number? If I take x as 3, 3 square is 9. 9 minus 2 is 7. 9 minus 2 is 7. Prime number is greater than 3. This case is not possible. If it is 5, if x value it is, what x square is just greater than p. What is the square value just greater than p? 9. 9 minus 5. 9 minus 5 it is nothing but 4. If it is, this value should be minimum. If it is p, these just square greater than 7 is 9 minus 7 is nothing but 2. 9 minus 7 is nothing but 2. I hope it is clear. X square is greater than p. X square minus p, it should be minimum value. Minimum value. Prime number is greater than 3. Greater than 3 is 5 and 7. So, what is the square function just greater than 5? 9. Square function just greater than 7. 9 minus 7 is 2. 2 is smaller compared to 4. So, answer for this question is 2. Answer for this question is nothing but 2. I hope the idea it is clear. Answer for this question is nothing but 2. Another beautiful question. 101 digits are chosen randomly, and two numbers a and b are formed using all the digits exactly once. The number of digits in a, the number of digits in a, and the number of digits in b. Combination is nothing but 101 digits. Combination is nothing but 101 digits. What is the probability such that a power 4 is equivalent to b? What is the probability such that a power 4 equivalent to b? Now we will see a concept. If a has n digits, a square will have either 2n or 2n minus 1 digits. It can be easily deduced by taking some examples. Suppose see here. For example, a is nothing but 11. 11 contains 2 digits. 11 square is nothing but 121. 121 it is nothing but 3 digits. 2 into 2 minus 1. If a is taking a 99 value, 99 is 2. 99 square is, a square is, 99 square is 9801. So it is 4 digits. If a takes n digits, a square will take 2n or 2n minus 1 digits. If I still square it, these is nothing but it will take 4n, it will take 4n minus 1, it will take 4n minus 2, or it will take 4n minus 3. 4n minus 1, 4n minus 2 and 4n plus 3. I hope it is clear, right? Now see here, sir. This is a power 4, these are the cases. How it is? Suppose for example, listen carefully sir, a square has got for example 100, a value is 10, right? A power 4 will have 1 followed by 4 zeros. A value is 10. So how many? 1, 2, 3, 4, 5. 5 digits I got. 5 digits I got. So which is nothing but a value is 10. 10 is nothing but 2. So 4 into 2 minus 3. Now listen carefully. Find the probability of a power 4 equivalent to b. These sum should be equivalent to 1. Now if it is 4n, 4n minus 1, 4n minus 2. Now if you see here, a is nothing but 13, a square is nothing but 169, a power 4 is nothing but 169 whole square, which is 2197 into 13. I will get these value, right? I will get these value. Now if you see here, 13 sevens are 91, 13 nines are 117, 126, 13 plus 12, 25, 2. 13 twos are 26 plus 2, 28. 28561 you got. What are the other numbers? Other numbers, if I take an other number combination of 3, 7 and 9, 4, will these both be equal? These both cannot be equal. So answer is nothing but big 0. You can take your own number and try to check it out, right? These a power 4 cannot be equivalent to b. A power 4 cannot be equivalent to b. I hope it is clear, right? A has got n digits, a square has got 2n or 2n minus 1 digits. A power 4 will have 4n or 4n minus 1, 4n minus 2, 4n minus 3. 101 is 5 into 20 plus 1. So that case is not possible. Next one. Find the largest prime number such that these is nothing but a 2009 factorial plus 2010 factorial plus 2011 factorial divided by p cube. This should be equivalent to 0. What is the final expression that we got? 2009 factorial 1 plus 2010, right? It is 2011 into 2010 into 2009 factorial. These what? Till here we got p cube. These 2009 factorial into 1 plus 2010 is 2011 into 1 plus 2010, the divided by p cube. These is nothing but a remainder of 2009 factorial into 2011 square divided by p cube equivalent to 0. P cube equivalent to 0. Now if you see here, largest prime number which I require, largest prime number. Now if you see, that means 2011, is it a prime number? 2011, we will check it out whether 2011 is a prime or a composite number, prime or composite. These is nothing but 44 square is 1936. So these is nothing but 43. These is nothing but 37. These is 31. I am writing all the prime numbers less than 44, 43, 41, 29 and so on up to 3, 2. Check it out. If not, what we will do is 2009 factorial should be divisible by a cube of a prime number. If it is divisible by a cube of a prime number, let me divide these 2009 by 3. 3 660s are 198, 29, which is 669 point something. These 3669 point something. What is the largest power of a prime number which will divide 2009 factorial? Just the value less than 669. Answer is 661. Answer is 661. 661. So if 2009 factorial should be divisible by a cube of a prime number. Suppose what will take? Suppose highest power of 8. Highest power of 8 in 20 factorial. 8 is 2 cube. So 20 it will become 10 2s are 2 5s are 2 2s are 1. 18 we will write it as 2 power 18, then we will do 2 cube power 6. Am I right? I am dividing this power by 18 by 3 only. So 2009 divided by 3, 669. So largest it is nothing but the prime number, just less than 669. So answer is 661. 667 is not a prime number. It is 29 into 23. It is 29 into 23. So answer is 661. I hope the idea it is clear. So 661 is the largest prime number which will divide this number. Why? Because 2009 when I divide by 661, it goes 3 times. It cannot go 4 times. 661 power 3 divided by 661 power 3. They both will be cancelled. So the answer is nothing but 0. Listen carefully to the question. How many integers less than 500 can be written as sum of two positive integer cubes? That means a cube plus b cube equivalent to k, right? K is less than 500. K is less than 500. Now if I list out all the perfect cubes, 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, 6 cube and 7 cube. 8 cube is 512. So A and B values can lie from 1 to 7. Why? Because if B value or A value is 8, 8 cube is 512, 512 plus something will get into a value greater than 500. So it is not said that they should be distinct. So A and B can be same or A and B could be distinct. That means if A is 1 cube, A cube is 1 cube, B cube can take all the values 1 cube, 2 cube till 7 cube. So these is nothing but total 7 values it can take. If it is 2 cube, it can take 1 cube, right? It can take 1 cube plus 2 cube we have already taken. So double counting, avoid it. It can take 2 cube, 3 cube and so on up to 7 cube. So 2 to 7 it will take 6 values. Next one 3 cube. 3 cube plus 1 cube already came in the first case. 3 cube plus 2 cube. The answer is nothing but equivalent to 2 cube plus 3 cube. These 3 cube, 4 cube, 5 cube, 6 cube and 7 cube, right? So total it is nothing but 5 cases. 4 cube is nothing but 4 cube, 5 cube, 6 cube and 7 cube. These is nothing but 4 cases. Wherever repetition is there, try to avoid it. 3 cube plus 4 cube, 4 cube plus 3 cube I have not taken. 5 cube, this can be 5 cube, 6 cube and 7 cube. So total 3 cases, right? 343 plus 125 is less than 500. Next one, if it is 6 cube, we can take 6 cube. 7 cube we should avoid it. Why? Because 6 cube plus 7 cube. 6 cube plus 7 cube is 216 plus 343, which is 559. The value should be less than 500. So these is nothing but one case. So 7 plus 6 13, 13 plus 5 18, 18 plus 4 22, 25 plus 1 26 cases. Total 26 cases are there which will satisfy this question. How many integers less than 500 can be written as sum of two positive integer cubes? Positive integer cube, a cube plus b cube equivalent to k. K should be less than 500. Step number 1, I found out all the cubes which will reach up to a maximum value. 8 cube is 512 because it is positive integer cubes. A and B cannot take 0. A and B can take all the values from 1 to 7. Don't do any double counting. Avoid double counting. Here 1 cube plus 2 cube. Here don't do 2 cube plus 1 cube. And A and B can be same. So 1 cube plus 1 cube. 2 cube plus 2 cube. Similarly, write 6 cube plus 7 cube. Please avoid it. Please avoid this question. Now the reason why this question is there is another similar CAT question, right? Based upon this, I think I kept it, but I'll discuss it right now. Please listen carefully, sir. how many values, if A, B, C are natural numbers, how many values A, B, C will take such that A cube plus B cube plus C cube is 2011. A, B, C are natural numbers. How many values A, B, C will take such that A cube plus B cube plus C cube equivalent to 2011. You can either use negative remainder concept, or in case if you know Euler theorem, this process will become little more easier. Negative remainder concept which we will use. Suppose if I divide a number by 9. If I divide a number by 9, right, and cube it, A divided by 9, I will get 0, 1, 2, 3, 4, 5, 6, 7 and 8. When you divide any number by 9, the possible remainders are 9 remainders from 0 to 8. 0 cube by 9, 0. 1 cube by 9, it is 1. 2 cube by 9, 2 cube is 8, which is minus 1. 3 cube is 27, 27 by 9, it is 0. 4 cube 64 by 9, which is 1. 5 cube 125, 125 digital sum is 8, which is minus 1. 6 cube is 216, 9 divided by 9, which is nothing but 0. This is 1 and it is minus 1. That means any number on cube when divided by 9, the possible remainders are 0, 1 and minus 1. 0, 1 and minus 1. 0, 1 and minus 1. So, any number on cube, the remainders are 0, 1 and minus 1. Similarly for B also, all the possible remainders are 0, 1 and minus 1. It is 0, 1 and minus 1. 0, 1 and minus 1. What is the lowest remainder that is possible? Minus 1, minus 1, minus 1, which is minus 3. So, answer can be of the form 9a minus 3. What is the highest remainder that is possible? Which is nothing but plus 3. Remainders oscillate between minus 3 to plus 3. But what is the remainder when it is divided by 4? What is the divisibility rule of 9? Sum of the digits should be divisible by 4. That means here left hand side negative reminders are from minus 3 to 3, but the right hand side it is nothing but 4. Answer is no value for ABC possible. Answer is no value for ABC possible. No value for ABC possible. Why? Because left hand side the remainders are moving from minus 3 to plus 3, but in the right hand side the value, the digital sum is nothing but 4. Because the digital sum is 4, digital sum is the remainder when you divide a number by 9. I divided A cube, B cube, C cube by 9. When you divide a number by 9, the possible remainder are 0, 1 and minus 1. You don't need to waste your time solving this. Directly by using Euler's Torsion function, you will definitely get 0, 1, minus 1 instead of substituting all this. Now see here. Listen carefully, sir. Suppose by using Euler's Torsion function, A, B, C are natural numbers. A cube plus B cube plus C cube equivalent to 2011. 2011. Now see here. According to Euler's Torsion function, if you know it, it is good. If you don't know, little bit of extra time is required to generate all the possible reminders. Reminder 1, a power 6 divided by 9, it is nothing but 1 or 0. These one, a and 9 are not co-prime to each other. A and 9 are not co-prime to each other. These where A and 9 are co-prime to each other. A and 9 are co-prime to each other. That means when you divide a number by 9, what are all the remainders possible? 0, 1, 2, 3, 4, 5, 6, 7 and 8. 0, 1, 2, 3, 4, 5, 6, 7 and 8. The two numbers are said to be co-prime if their HCF is 1. 0 divided by 9, which is 0, right? So perfectly not co-prime, perfectly divisible. 1 and 9, they are co-prime. 1 power 6 by 9, 1. You don't need to write. 2 and 9 are co-prime, remainder 1. 3 and 9 are not co-prime. 3 power 6 is perfectly divisible by 9. I hope it is clear. 4 and 9 are co-prime. Directly it is 1. 5 and 9 are co-prime. Directly it is 1. 6 and 9 are not co-prime. It is 0. 7 and 9 are co-prime. Directly 1. 8 and 9 are not co-prime. 1. So, these 6 is nothing but the quotient function of 9. How you got 6? 9 is nothing but 3 square number of numbers which are less than n and co-prime to n, which are nothing but 6. In the remainder class, I have discussed everything. That means, remainder when a power 6 divided by 9, if it is 0 and 1, think logically. What is a power 3 divided by 9? A power 3 whole square is a power 6. 0 square will be 0. Something square is 1. That means it can be minus 1 or 1. So directly you can write a power 3 divided by 9 is minus 1 or 1. If I square it, 0 square is 0, minus 1 square is 1, and 1 square is also 1. So directly you can say that the possible remainders are 0, 1, minus 1. 3 variables are there. Minus 1 into 3, minus 3. Plus 1 into 3, plus 3. Minus 3 to plus 3. Remainders oscillate from minus 3 to plus 3. But the right hand side it is 4. Answer is no. Values of A, B and C are possible. I will again come back to this kind of questions after certain time. Especially integral solution problems are the highly repeated problems in CAT and XAT and some other management examinations. Various forms of integral solutions questions are asked. I hope this is clear. From this A cube plus B cube equivalent to K. So we have extended it to, right? 3 variables and try to solve. Next, see here. This is a beautiful question. Most of the questions probably you might not have seen anywhere else. In how many ways 10 lakhs, which is nothing but 10 power 6, can be expressed as a sum of a square number and a prime number. So P is nothing but a prime number. P is nothing but a prime number. The definition of a prime number is it has got only 2 distinct factors, 1 and itself. It has got only 2 distinct factors, that is 1 and itself. Because it has got 2 factors, 1 and itself, let us try to factorize into a product of 2 factors. 10 power 6 minus a square, it is nothing but P. This is nothing but 10 cube minus a into 10 cube plus a, which is nothing but P. P is a prime number. P is a prime number. Because P is a prime number, 1 into number itself, 1 into number itself, or number itself into 1. Number itself into 1. This second it is incorrect. Why? Because 10 cube plus a, if a is an integer, right square of a number, a is an integer, 10 cube plus a is always greater than 10 cube minus a. So it is 1 into itself. That means 10 cube minus a, it is nothing but 1. 10 cube is 1000. 1000 minus 1 is a. A is nothing but 999. A is nothing but 999. Only one way I can express it as a sum of a square number and a prime number. In only one way I can express it as a sum of a square number and a prime number. Very, very good question, sir. A prime number has got only 2 distinct factors, that is 1 and itself. 1 into number itself into 1. That means 1 I am giving it to 10 cube plus a. Number itself I am giving it to 10 cube minus a. Second part is definitely greater than the first part. So second case will not come. 10 cube minus a is 1. So 1000 minus 1 is a is 999. A is 999. If you substitute the value 10 cube whole square minus 999 whole square, which is nothing but P. This is nothing but 10 cube minus 999, and next one is 10 cube plus 999. So these is nothing but 1000 plus 999, 1999. So 1999. 1999, it should be a prime number to satisfy this case. I hope it is clear. Similarly, another question can also be developed. Wherever a question is there, I will create some more questions of the same idea. For how many values of n? For how many values of n is n square minus 3n plus 2 a prime number? For how many integral values of n? For how many integral values of n is n square minus 3n plus 2 a prime number? N square minus 3n plus 2. Degree of this expression is 2. If the degree of the expression is 2, write the equation as a product of two factors. So n square minus 3n plus 2. This is nothing but n minus 1 into n minus 2. Right? And this is a prime number. This is a prime number. So prime number has got only two distinct factors, 1 and the number itself. 1 and the number itself. So it can be 1 into number itself or number itself into 1. So if n minus 1 is 1, n value will become 2. Check it out what is happening to n square minus 3n plus 2. 6 minus 6 is 0. 0 is not a prime number. This case is not possible. If n minus 2 is 1, n value will become 3. This is nothing but 3 square minus 3 into 3 plus 2. 9 cancel. It is 2. n2 is nothing but a prime number. How many prime values of n such that this expression is an prime number? There is only one value and the value of n is nothing but 3. Same way to solve the previous question. Right? Degree of the expression is 2. If the degree it is 2, write the equation as a product of two factors. Definition of a prime number is, prime number can be written as 1 into itself or number itself into 1. This is the definition of a prime number. So either n minus 1 is 1 or n minus 2 is 1. N minus 1 is not giving me an expression a prime number. I hope it is clear. Right? This is how the last 3 years. This question already we solved it. Already we solved this kind of question. Answer is nothing but 0. Answer is nothing but 0. So lot of questions are also asked based on the cube of a logic. Let us develop another question. Please write down a note. X cube 50 plus x whole cube. X cube 50 plus x whole cube has same last two digits. Has same last two digits if x is even. This is another exact model question. X cube and 50 plus x whole cube has same last two digits if x is even. If x is even. Only if x is even, right? 50 plus x whole cube and x cube has got the same last two digits if x is even. Why it is happening? Please see the proof. Once you understand it, then you can solve the problem. X cube, next is 50 plus x whole cube. 50 plus x whole cube is a cube. Next is 3a square b. Next is 3ab square. And next is nothing but b cube. Now if you see here, listen carefully, sir. The last two digits of a number, if you want the last two digits of a number, any number, it is nothing but the remainder when you divide a number by 100. Last two digits of any number, it is the remainder when you divide a number by 100. 50 cube, perfectly divisible by 100. 50 square, perfectly divisible by 100. X is even. Even number on square, it is divisible by 4. 4 into 50, it is divisible by 100. Because x is becoming even, 50 into even number square, this number is becoming multiple of 100. Extremely important key point, sir. Lot of students will spend a lot of time on this kind of problems in counting. You don't need to count it. X cube and 50 plus x whole cube has same last two digits if x is even. X cube and 50 plus x whole cube has same last two digits if x is even. Write down a question. How many 3-digit numbers? How many 3-digit numbers? How many 3-digit numbers on cubing? How many 3-digit numbers on cubing ends with 28? How many 3-digit numbers on cubing ends with 28? How many 3-digit numbers on cubing ends with 28? So what is the logic we discussed? X cube and 50 plus x whole cube. This is the idea. They will have same last 2 digits. X cube and 50 plus x whole cube. They will have the same last 2 digits if x is even. If x is even. Now see here. It is ending with 28. What is the lowest natural number on cube? I will end with 8. 2 cube is 8. I want 28. Next number is 12. We all know that 12 cube is 1728. 12 cube is 1728. Yes, we got 12 cube. What is the next number that will be on cube? I will get the same last 2 digits, 62 cube. But he is asking that it is a 3-digit number. Hundreds place can range from 1 to 9. I hope it is clear. Right, similarly, here also hundreds place can range from 1 to 9. 1 to 9. So it can be 12 cube or 62 cube. So 112, 162, 212, 262, 912, 962. Here 9 numbers are there, here 9 numbers are there. 9 plus 9, because it is fundamental principle of addition. Answer is nothing but 18. Directly you will get the answer as 18 if you know this logic. Otherwise you will think that this question is a very time consuming question. How many 3-digit numbers on cubing ends with 28? Logic is x cube and 50 plus x whole cube has same last 2 digits if x is even. 2 cube is 8. 12 cube is nothing but 1728. Right? I hope it is clear. Kindly reply in the live chat if it is clear. Praveen? 9 plus 9. Similarly, please try to solve the question. How many 3-digit numbers on cubing ends with 44? 14 cube is 2744. 14 cube. Next is 64 cube. 114 cube. 164 cube. Like that, the process answer will be 18. I hope the idea it is clear. Right? Cube related, another wonderful concept based on a cube related. Idea is clear, right? Next one. Another question. How many pairs of non-negative integers? Non-negative integers. Non-negative integers, it is nothing but non-negative, other than negative integers. It is also nothing but a whole number solutions. It is nothing but whole number solutions. Now see here. First key point. Whenever you get this kind of equations, xy minus 7 whole square is x square plus y square. Now if you observe, so open the bracket, x square y square minus 14xy plus 149, it is nothing but x square plus y square. So these is nothing but x square y square minus 12xy minus 12xy. So these plus 49, these nothing but x square plus y square, x square plus y square, these plus 2xy. I hope it is clear. Plus 2xy. Idea is clear, right? So these nothing but xy minus 6 whole square plus 13, it is nothing but x plus y whole square. X plus y whole square. 13 again it is a prime number. So these nothing but x plus y whole square minus of xy minus 6 whole square, which is nothing but 13. A square minus b square. A plus b. X plus y plus xy minus 6. A minus b. X plus y minus xy plus 6, which is nothing but 13, which is 1 into 13 or 13 into 1. First term can be 1 or the second term can be 1. Suppose if the first term is 1, x plus y plus xy minus 6 if it is 1, these is nothing but x plus y plus xy equivalent to 7. So if I add 1 on both the sides, 1 plus x into 1 plus y, it is nothing but 8. 8 is 1 into 8, 2 into 4, 4 into 2 and 8 into 1. 1 plus x is 1, x value it is 0. 1 plus y y is 1, y value is 0. So 1 plus x1, x value will become 1. 1 plus y is 4, y value will become 3. X is 1, y is 3. Next case, if x is 3, y is 1. X is 1, y is 3. X is 3, y is 1. This I got for the case 1 into 13. These I got it for the case 1 into 13. Just check it out. Just check it out. 1 minute, sir. I hope the idea it is clear, right? A square minus b square. So this I took it as 1. That means this it should be 13. Let us check. X plus y minus xy plus 6, it has to be 13. Check the values. If you are getting, that is the pair. If you are not getting the value, that is not the answer. I hope the idea it is clear. Always remember, sir, right? Whenever I will tell it once it is clear to you, right? X square y square minus 14xy plus 49 is x square plus y square minus 12xy, it is plus 2xy. Xy minus 6 whole square plus 13 is x plus y whole square. X plus y whole square minus of xy minus 6 whole square. These a square minus b square, a plus b into a minus b. Still I did not complete it, I just gave an idea. If it is 1, this is the process we have to do. For me, very important is this step, sir. Adding 1 on both the sides. Adding 1 on both the sides. Please write down some important key points. Please write down some important key points which will help you to get the answer fast. Please write down some important key points. In this kind of questions, for you to get the answer fast, these key points will help you. First key point. Number of ways of writing a number. Number of ways of writing a number. Number of ways of writing a number as a product of two natural numbers. As a product of two natural numbers. It is nothing but number of factors. It is nothing but number of factors. If wherever variables are present in the question, use this logic. If variables are present in the question, this is nothing but an ordered pair. This is nothing but an ordered pair. It is two natural numbers. Suppose if it is two integers, this is nothing but 2 times the number of factors. It is nothing but 2 times the number of factors. Positive into positive is one way, negative into negative is another way. That's why it is 2 times the number of factors. First key point, if the degree of the equation is 2, write the equation as a product of 2 factors. Write the equation as a product of 2 factors. Another concept. Write the equation as a product of 2 factors. Whenever the degree of the equation is 2, write the equation as a product of 2 factors. Second important key point. Third key point. If the equation is of the form a by x plus b by y equivalent to 1 by c, directly write the equation as x minus ac into y minus bc equivalent to a into b into c square. A into b into c square. Answer is a into b into c square. How many integral solutions for xy? Directly you can tell it as how many integral solutions will be there for this equation. Answer is nothing but 2 into number of factors minus 1. 2 into number of factors for this number minus 1. 2 into number of factors minus 1. Please make a note of these 3 important key points. If you know these 3 important key points, you can solve a lot of problems very fast. First point is, in how many ways can you write a number as a product of 2 natural numbers, number of factors, product of 2 integers, twice the number of factors. If the degree of the equation is 2, write the equation as a product of 2 factors. Third one, if the equation contains variables in the denominator, this is the right form of the equation. One by one, we will solve a few problems so that you will understand these 3 concepts clearly. Application. First one, x into y equivalent to 120. X and y are natural numbers. X into y is 120. Xy are natural numbers. How many values xy will take? 120, it is nothing but 2 cube into 3 into 5. So in how many ways can you write a number as a product of two natural numbers? It is nothing but number of factors. 4 into 2 into 2. Answer is nothing but 16. First one, answer is nothing but 16. I hope the idea it is clear. X into y equivalent to 120. Xy are integers. How many values xy will take? How many values xy will take? 120 is 2 cube into 3 into 5. So the number of factors will be 4 into 2 into 2, 16. 16 will be positive into positive. Negative into negative also there will be 16. Answer is nothing but 32. First key point and its application. First key point and its application. If it is natural numbers, only positive values. If it is an integer, positive into positive and negative into negative. 32. First key point, if it, I hope it is clear, right? Only when you understand the concept and apply for it, your ability to use the concept will grow, right, exponentially. X plus y plus xy equivalent to 143. Xy are natural numbers. How many values xy will take? How many values xy will take? X plus y plus xy equivalent to 143. Degree of the equation is 2. If the degree of the equation is 2, write the equation as a product of two factors. Add 1 on both the sides. So it is x plus 1 into y plus 1 is 144, which is nothing but 2 power 4 into 3 square. So 5 into 3, which is nothing but 15. 15 values xy will take, x and y, right? If out of these 15 values, now see here, 1 into 144, right? 2 into 72. Now listen carefully, sir, and so on. 3 into 48. Are there any cases where x and y are zeros also? We will eliminate it. X plus 1 is 1. X plus 1 into y plus 1 is 1 into 144. Right? If xy are natural numbers, x cannot take 0, y cannot take 0. That means 15 will be the answer if xy are integers. 13 will be the answer if x and y are natural numbers. If x and y are natural numbers, x cannot take 0, y cannot take 0. We got the answer 15 when x and y are integers. Out of this, x plus y is 1, x value will be 0. That is not possible. So if x is 0, y will be 143. X cannot take 0, y cannot take 0. So answer is 13. I hope these also clear. Second one. One more example. 2xy minus 5x plus y is nothing but 55. Original exact question. X if I take common, these 2y minus 5. I need to write down as a product of two factors. So 2y minus 5. Half I have to take common because it is y. Minus 5 by 2 is there on the left hand side. It should be there on the right hand side. So it is x plus 1 by 2 into 2y minus 5 equivalent to 105 by 2. These are nothing but 2x plus 1 into 2y minus 5. 2x plus 1 is odd, 2y minus 5 is odd. So all the factors 3 into 5 into 7. These are nothing but 2 into 2 into 2. If x and y are integer, we want the integral solutions. If I want the integral solutions, into 2 I will do. Answer for this question is nothing but 16. Answer for this question is nothing but 60. I hope the idea is clear. If the degree of the equation is 2, write the equation as a product of two factors. If the degree of the equation is 2, write the equation as a product of two factors. Idea clear, right? Extremely important logics. If you are enjoying this problem solving, kindly like our video and share it with all the friends. Entire July, good number of mock CAT video solution questions I will do it. I will take a question, I will discuss a concept, then I will solve the question, then I will create some more questions based on that concept, so that you will have an holistic understanding of this concept. Based upon this one, I am creating multiple questions so that it will be useful for you. 1 by x plus 1 by y equivalent to 1 by 12. X and y are integers. X and y are integers. These are nothing but x minus AC, y minus BC. It is nothing but a into b into c square. So these are nothing but x minus 12 into y minus 12 equivalent to 12 is 2 square into 3 whole square. So 2 power 4 into 3 square. Integer, right? So 2 into number of factors minus 1. Minus 1 is nothing but a solution. Minus 12 into minus 12. Because it's a perfect square. X and y both will be 0 at the same time. So answer for this question is nothing but 29. Answer for this question is nothing but 29. Idea clear, right? If x, y are integral solution. Now you can probably, when you get this kind of question, you know the approach how to solve these questions. Right? Another one. What is the 50th digit after the decimal for 2009 into 2010 into 2011 into 2012 plus 1 when divided by 4. Plus 1 when divided by 4. Let 2009 is nothing but x. X is nothing but an odd number, sir, which we are going to use this logic. So these are nothing but root of x into x plus 1 into x plus 2 into x plus 3 plus 1 when divided by 4. First and last, if I take, these are nothing but x square plus 3x into x square plus 3x plus 2 plus 1 divided by 4. These, if I take it as a, these are nothing but a square plus 2a plus 1 divided by 4. These are nothing but a plus 1 by 2. A plus 1 by 2. A is nothing but x square plus 3x. X square plus 3x plus 1 by 2. X square plus 3x plus 1 by 2. This is the value of the question. This is the value of the question. Now if you see here, right, x is nothing but an odd number. Odd on square, it is an odd number. 3 into odd, it is an odd number. Plus 1 divided by 2. Plus 1 divided by 2. Odd plus odd is even. Even plus 1 is odd. Odd divided by 2. Odd divided by 2. 3 divided by 2, which is 1.5. 7 divided by 2, it is 1.5. That means after decimal, it will be 5. Remaining all will be zeros. 50th digit after the decimal. Answer is nothing but 0. Answer is nothing but 0. I hope the idea it is clear. 2009 is x. X into x plus 1 into x plus 2 into x plus 3 plus 1 by 2. X square plus 3x is a. These are nothing but a plus 1 by 2. A is nothing but x square plus 3x. X is an odd number. Odd plus odd even. Even plus 1 odd. Odd number divided by 2. You divide any odd number divided by 2. After dot, the first digit will be 5. Remaining all, it will be 0, 0, 0, 0, zeros. So answer is nothing but 0. Very, very good question, sir. Most of these questions you will not find in the regular textbook, right? You will realize this once you solve more and more problems. Another question. This is a question based on geometry. one side of a triangle, there is a triangle length. One side has got length 75. Of the other two sides, the length of one is double the length of the other. If length of one is x, the next one other is nothing but 2x. So what is the maximum possible area of this triangle? So area of a triangle, it is given by Heron's formula, s into s minus a into s minus b into s minus c. Only one side is known to us, other two sides we don't know. So these is nothing but root of 2s is nothing but the perimeter, which is 3x plus 75. So s is nothing but 3x plus 75 by 2. So these is nothing but 3x plus 75 by 2 into s minus a. 3x plus 75 by 2 minus 3x plus 75 by 2 minus 75. Next it is 3x plus 75 by 2 minus x. Next it is 3x plus 75 by 2 minus 2x. Now if you observe, there is some kind of beautiful observation in the root value that we will derive. Now if you see here, this is 3x plus 75. If I take to LCM, 75 minus 150, minus 150, 75 minus 150 minus 75. That means if I do first and second, these is nothing but 3x plus 75, 3x minus 75 divided by 4. Next one, 3x plus 75 minus 2x. These is nothing but x plus 75. Next is nothing but 3x plus 75 minus 4x. So 75 minus x divided by 4. Divided by 4. That means these is nothing but root of 9x square minus 75 square into 75 square minus x square. 75 square minus x square divided by 16. I hope it is clear here. Once you understand this, you got the answer. Now it is nothing but area is nothing but root of 9x square minus 75 square into 75 square minus x square divided by 16 minus 75 square into 75 square minus x square. Now see here, there is a note. There is a note. A power p, b power q, c power r, it is maximum. It is maximum only when a by p equivalent to b by q equivalent to c by r, and a plus b plus c should be constant, and a plus b plus c should be constant. So what you do is you multiply this by 9 and divide it by 9. So if I multiply it, this is nothing but 1 by 12 into root of 9x square minus 75 square into 9 into 75 square minus 9x square. I hope it is clear. Now the same concept can be used. Product is maximum when the sum of the variables is constant. 9x square minus 9x square, it is cancelled out and the variables are equal. 9x square minus 75 square is 9 into 75 square minus 9 into x square. So 18x square equivalent to 9 into 75 square plus 75 square. From there you will get the value of x square, substitute it, you will get the answer. Product of the variables should be maximum. For the product should be maximum, sum of the variables should be constant. If I take like this, 9x square minus x square, I am getting a variable. So I multiplied it and divided by 9. 9 into 75 square minus 9x square plus 9x square minus 9x square cancelled out, this will be the same. I hope it is clear. A plus B plus C is constant. 9x square minus 75 square plus 9 into 75 square minus 9x square. I hope the idea it is clear. I hope the idea it is clear. Why I multiplied and divided. Beautiful questions, sir, where the rule of AM, GM, HM is used. If the variables are positive real numbers, product of the variables, it is maximum when the sum is, if the sum is constant and the variables are equal. I hope the idea it is clear. Next one, how many ordered triplets of ABC of positive odd integers satisfy A plus B plus C equivalent to 23? Concept. A plus B equivalent to 4, A plus B equivalent to 4, A greater than or equivalent to 1, B greater than or equivalent to 1. If the variables are starting from 1, generic solution is 1 plus 3, 4, 2 plus 2, 4, 3 plus 1, 4. Totally how many solutions I got? Positive integral solutions 3. Suppose if the question is A plus B equivalent to 4, A is greater than or equivalent to 0, B is greater than or equivalent to 0. How many solutions we will get? 0 plus 4, 1 plus 3, 2 plus 2, 3 plus 1, 4 plus 0. You don't need to use any separate formula for this. This can be solved like this. X can be written as A plus 1. X is greater than or equivalent to 1. B from 0 convert into Y. B can be written as B plus 1. Y is greater than or equivalent to 1. So A is X minus 1. B is Y minus 1 equivalent to 4. X and Y are greater than or equivalent to 1. X plus Y equivalent to 6. 6 means, how you got 3? 4 balls are kept in a line. There are 3 gaps. Select any one gap, you will get one solution. X plus Y equivalent to 6. 6 balls are kept in a line. There are 5 gaps. Select any one gap, you will get one integral solution, 5C1. 5C1. I hope the idea is clear. The variables should start from 1. If the variables are starting from 1, you can use this beautiful gap method to solve a lot of problems, sir. You can use this gap method to solve a lot of problems. A plus B equivalent to 4. 4 balls are kept in a line. There are 3 gaps. Select any one gap. If I select this gap, 1 plus 3, one solution. If I select this gap, 2 plus 2, another solution. If I select this gap, 3 plus 1, another solution. If 4 balls are kept in a line, there are 3 gaps. Select any one. You don't need to do all these variable change also. Directly you will get the answer. What is that concept also we will see. It is starting from 0. Add 1, add 1. 4 plus 2, it is nothing but 6. If 6 balls are kept in a line, 5 gaps are there, select any one. I will do some more problems whether to make it clear, then we will solve these mock CAT-1 question. Examples. Suppose if the question is A plus B equivalent to 8. A is starting from 0. B is starting from 0. 0 means I need to add 1. 0 means I need to add 1. To 8 I am adding 2. 10. 10 balls are kept in a line. There are 9 gaps. Select any one. Answer is 9C1. Next one. A plus B plus C. It is nothing but 12. A is greater than or equivalent to 4. B is greater than or equivalent to 2. C is greater than or equivalent to 3. 3. I want the integral solution for this equation. I want the integral solution for this equation. A is greater than or equivalent to 4. B is greater than or equivalent to 2. C is greater than or equivalent to 3. 4 means I need to decrease 3. I need to decrease 1. I need to decrease 2. Total I decreased 6. 12, 6 decreased, which is 6. 6 balls are there in a line. There are 5 gaps. 2 variables, 1 cut, 3 variables, 2 cut. Answer is 5C2. Single shot, straightforward, you will get the answer. Just by looking at the question itself, you will get the answer. We started with when the variables are starting from 1. Then we did the variables could start from anything. Lower limit and upper limit, if both are given also, you can solve it, which I will solve it in the permutation and combinations for the enrolled students when I discuss. I hope it is clear. Now we will solve the question that is present. Once you understand, this is a very, very easy logic, sir. Idea clear, right? Now we will solve. A plus B plus C is 23. Variables, if it is starting from 1, it is easy for us. So it is 2k1 minus 1. K1 greater than or equivalent to 1. Even if you take 2k1 plus 1, that also will give an answer. That also we will discuss. 2k2 minus 1. K2 greater than or equivalent to 1. C is 2k3 minus 1. K3 greater than or equivalent to 1. So these is nothing but 2 into K1 plus K2 plus K3 minus 3 is nothing but 23. So K1 plus K2 plus K3, 26 by 2, which is 13. Answer is nothing but 12C2. Answer is nothing but 12C2. I hope the idea it is clear. If the variables are starting from 1, 2 into K1 plus K2 plus K3 minus 3, if it goes to the right hand side, it will become plus 3. 26 by 2, 13. 13 balls are kept in a line. There are 12 gaps. So it is 12C2. 12C2. I hope this idea it is clear. What if it is 2K1 plus 1? That also answer will not change. A plus B plus C, which is 23. A is nothing but 2K1 plus 1. B is nothing but 2K2 plus 1. C is nothing but 2K3 plus 1. Variables are starting from 0. K1, K2, K3, they are starting from 0. So these are nothing but 2 into K1 plus K2 plus K3 minus 3. It is 20. So K1 plus K2 plus K3, which is nothing but 10. These all start from 0. If it is starting from 0, what should we do? We should add 1. So 10 plus 3 is 13. 13 means again 12C2. Again 12C2. Even when the variables are starting from 1 or the variables are starting from zeros, answer will not change. Answer will not change. So you don't need to worry whether it is starting from 0, add 1. If it is starting from any other value, make it into 1 and optimize the equation. So if 23 are there, there are 22 variables are there. So for 3 variables, I require 2 cuts. If it is a positive integral solution. I hope this idea it is clear. Multinomial theorem, please avoid it. Avoid using multinomial theorem. Next one. A palindrome is a number which reads same forward and backward in a letters. Liril is a palindrome. Amma is a palindrome. Anna is a palindrome. Okay, in numerical values, 121 is a 3-digit palindrome. 3-digit means left to right, right to left. Both should be same. So ABA, it is a 3-digit palindrome. Okay. ABA, it is a 3-digit palindrome. Now what is that he is asking? What is the sum of all 3-digit palindromes which are multiples of 13? I want all the 3-digit palindromes which are multiples of 13. A is there in units place, B is there in tens place, A is there in hundreds place. So these are nothing but 100A plus 10B plus A. This is nothing but 91A plus 9A plus A plus 10B. These is nothing but 91A plus 10 into A plus B. And it is divisible by 13. It is divisible by 13. Now if you observe, 91 is divisible by 13. 10 is not divisible by 13. Conclusion is A plus B should be divisible by 13. A plus B should be divisible by 13. What are A and B here? A and B here are digits. A and B here are digits. It will range from which values? 1 to 9. It will range from 1 to 9. A is there in the leftmost. 1 plus 12, 13. Not possible. B upper limit is 9. 2 plus 11. Not possible. 3 plus 10. Not possible. Next it is nothing but 4 plus 9. Possible. 5 plus 8. Possible. 6 plus 7. Possible. 9 plus 4. It is also possible. 8 plus 5, it is also possible. 7 plus 6, it is also possible. So what are all the various numbers? A, B, A, it is the 3-digit number. First one, 494. Next one, A, B, A, 949. Next one, A, B, A, 585. Next one, 8 and 5 also possible. 8, 5, A, 8, B, 5. Next it is 8. Right? Next one, 6, A, B, A, 676. Next it is nothing but 767. 767. One needs to add all the numbers. Now I am introducing a concept. A is there in units place. 4 is there in units place. 4 is there in tens place. 4 is there in hundreds place. Units place, tens place, hundreds place. Hundreds place value is 100. Tens place 10. Units place 1. 100 plus 10 plus 1. 111. Like that 111, 4 is shifting from units, tens and hundreds. 5 is shifting from units, tens and 100. 6 is shifting from units, tens and 100. 7 is shifting from units, tens and 100. 8 is shifting from units, tens and 100. These are nothing but 111 into 15, 20, 30. 8 plus 7, 15. And 9 is also shifting. So 15, 20, 39. 111 into 39, whatever the answer that you get, that itself is the answer. I hope the idea is clear. First we are finding the 3-digit palindrome. 3-digit palindrome is of the form A, B, A. A is there in hundreds place. 100A, 10B and A. 100A plus 10B plus A. 91A plus 10 into A plus B. Divisible by 13. A plus B should be divisible by 13. A plus B should be divisible by 13. I hope it is clear, Praveen. Idea is clear, right? Charging better. This concept is clear. Why 111 came into picture? 4 is there in units, tens and 100. 5 is there in units, tens and 100. 6 is there in units, tens and 100. 7 is there in units, tens and 100. 8 also units, tens and 100. 9 also units, tens and 100. Next one. I hope you are all enjoying the CAT level special questions. Now, next one. How many pair of positive integers are there such that the LCM is 2012? 2012. Now see, 2012 is nothing but 2 into 1006. These are nothing but 2 into 503. These are nothing but 2 square into 503. 2 square into 503. LCM of A comma B. I will tell you traditional method, then I will tell you an optimal method. LCM of A comma B is 2012. One is the traditional method. One is the traditional method. In the traditional method, A we don't know, B we don't know, but the LCM of A comma B is 2013, which is 2 square into 503. 2 square into 503. What is the definition of LCM? LCM always takes highest power of the given prime basis. LCM always takes highest power of the given prime basis. Answer is 2 square into 5 power 3. Question also it should have Right, 2 power. 503. Question also it should have 503 power. 503 y1 y2. LCM always takes the highest power of the given prime bases. Maximum of x1 and x2 it is 2. That means if x1 it is 2, x2 can be 0, 1, 2. Am I right? 2 square, highest is 2 square. 2 square, 2 power 0, highest is 2 square. Similarly, if x2 is 2, x1 can be 0, 1, 2. But 2 comma 2 it is double written. So it is 5 cases. What are the 5 cases? 2 comma 0, 2 comma 1, 2 comma 2, 0 comma 2 and 1 comma 2. I hope it is clear. Similarly, maximum of y1 and y2 it is 1. So if y1 is 1, y2 is 0 and 1. If y2 is 1, y1 is 0 and 1. So this is nothing but 1 comma 1 it is eliminated. 5 into 4. 5 into 4. 1 0 1 1 and 1 0 1 1 and 0 1. 3 cases. 5 into 3 is total 15 cases. This is the traditional method from the definition of LCM. LC always takes the highest power of the given prime bases. LCM always takes the highest power of the given prime bases. First I factorized 2012 as 2 square into 503. A and B. 2 square is there in the answer. Maximum of x1 and x2 it should be 2. y1 and y2 it should be 1. y1 and y2 it should be 1. 5 into 3, 15. But you can also do it in a quicker method. That also we will discuss. Please observe, in all these doublets, x1 is 2 or x2 is 2. In these doublet, x1 is 2 or x2 is 2. Right? In these doublet, 1 is present in every doublet. Now, please write down, sir. Please write down. These is nothing but LCM of A comma B, which is nothing but 2012, which is nothing but 2 square into 503. 2 square into 503. That means, that says that at least one of A comma B should contain, at least one of A comma B should contain 2 square into 503 power 1. At least one of A comma B should contain 2 square into 503 power 1. At least one is nothing but total minus none. At least one is nothing but total minus none. Total how many powers of 2 can be distributed on 2A? 2 power 0, 2 power 1, 2 power 2. B also 2 power 0, 2 power 1, 2 power 2. None. None means don't take 2 power 2. 2 power 0, 2 power 1. 2 power 0, 2 power 1. So, these is nothing but 3 square minus 2 square. Right? Total minus not taking the highest power. Again 5 also. 503 power 0. 503 power 1 for A. 503 power 0. 503 power 1. Total minus not taking 5 power 1. This is nothing but 2 square minus 1 square. 2 square minus 1 square. 9 minus 4, 5. 4 minus 1, 3. 5 into 3 is nothing but 15. At least one is nothing but total minus none. At least one is nothing but total minus none. Total all the powers of 2 onto A and B. Similarly, don't take 2 square. Don't take. At least one should contain 2 square means all the powers of 2 minus do not take powers of 2. Total minus 1. At least one student sitting in my class should get an 100 percentile in maths. Total. How many students attended the class? Minus none of the students who got the 100 percentile. I hope it is clear. Right? Is it clear? Right? 2 power 0. Total minus 9. This is an extremely important logic. If you know this logic, some complex questions, you can solve it very, very easily. We can further simplify. Now, I will further simplify. See here, sir. LCM of A comma B is 2 square into 503. What is that I am using concept? Total minus none. Listen carefully, sir. If you know this, next 5 problems are very, very easy to you. Total. First we will start with the first prime base. Total 2 square, 2 power 0, 2 power 1, 2 power 2. A can take 3 cases. B can take 3 cases. Total cases are 9, distributing all the powers of 2. Minus none. Don't take 2 square. A can take 2 cases. B can take 2 cases. 9 minus 4 is 5. I hope it is clear. Into total 503 power 1. A can take 2 cases. B can take 2 cases. A can take 1 case. B can take 1 case. 5 into 3. It is nothing but 15. It is nothing but 15. Now we will solve 5 problems. First problem. LCM of A comma B is nothing but 72. 72 is 2 cube into 3 square. 2 cube into 3 square. Total 2 power 3. 2 power 0 to 2 power 3. A can take 4 cases. B can also take 4 cases. Minus. Don't take 2 power 3. 0 to 2. 3 cases. B also can take 0 to 3. 3 power 2. A can take 0 to 2. 3 cases. B can take 0 to 2. 3 cases. Similarly, write 0 to 1, 0 to 1. I hope single step how you are getting. 16 minus 9 is 7. 9 minus 4 is 5. 35 values. Pairs it will take. Second question. Second one. LCM of ABC. It is nothing but 100. 100 is nothing but 2 square into 5 square. 2 square into 5 square. What is the concept that we are using? We are using total minus none. We are using total minus none. A will take from 0 to 2, 3 cases. B will also take 3. C will also take 3. A will take 2 square, 2 cases. B 2 cases, C 2 cases. I hope it is clear. Into 5 square, 0 to 2. 3 cases. 3 into 3 into 3. Since the power is same, it will be the same. 2 into 2 into 2. So these 27 minus 8, 19. 19 square is 361. 19 square is 361. LCM of A, B, C, D. It is nothing but 2 cube into 3 square into 5 power 1. 2 cube into 3 square into 5 power 1. A will take 0 to 3, 4. 4 variables are there. Don't take 2 power 3. Similarly, 3 square, 0 to 2, 3. Right, don't take 3 square. 0 to 1, 2. 2 power 4 minus 1 power 4. I hope the idea it is crystal clear. A 2 minutes problem became an 30 seconds problem with this negation approach, which is total minus none. Which is total minus none. Now you can develop as many questions as possible and you can solve it. Next one. Find the sum of all the digits in the decimal representation of all the positive integers less than 1000. Positive integers means we will start with 1, 1, 2, 3, 4, 5, 6 and so on up to 996, 997, 998, 999,000. Sum of all the digits. Sum of all the digits. First let us see how many times the digit will appear in all the natural numbers from 1 to 1000. First we will see how many times the digit 3 will appear. How many times the digit 3 will appear, let us see. Or first a digit n will appear. N could be anything. We will take some examples. How many times the digit n will appear? If n it is 3. Units place, tens place, hundreds place. If units place, if it is 3, this can be from 0 to 9. This can be from 0 to 9. If the leftmost is 0, I will get all the possible 2-digit numbers. If both are 0 zeros, I will get all the single digit numbers. So 10 into 10, 100. 10 into 10, 100. Similarly, tens place it can have 3. Hundreds place it can have 3. Here also it is 0 to 9. Here also 0 to 9. Here also 0 to 9. Here also 0 to 9. So 100, 100, 100. 100 plus 100 plus 100. It is 300. A doubt might get in for a student. Sir, you are doing triple 3 times. Triple 3 is counted thrice because digit 3 is present thrice. I hope it is clear. It is not how many numbers contain digit 3. How many times the digit 3 is present. In 33, 3 is present twice. So 33 is counted twice. 333, the digit is counted thrice. So 333 is counted thrice. Any single non-zero digit will appear from 1 to, I hope it is clear, any single non-zero digit will appear from 1 to 999. How many times? 300 times the digit will appear. 300 times which all digits will appear? 1 can appear, 2 can appear, 3 can appear, 9 can appear. If I take 0, 0 into 300, 0. So answer is nothing but sum of all the digits, 300 into 45. Easy question. If you know the logic, you can solve it. From all the natural numbers from 1 to 999, every single digit appears 300 times. Any digit appears 300 times. Appears 300 times. A digit appears 300 times from 1 to 999. From 1 to 999. Digit could be from 1 to 9. If you know this concept, this question is easy to you. I hope the idea it is clear. Next one. Let A, B, C, D are 4 real numbers. Okay. A plus B plus C plus D is 8. AB plus AC, combination of 2 it is given. So I will do A plus B plus C plus D. Whole square, it is nothing but A square plus B square plus C square plus D square plus 2 into the entire combinations of 2. 4 variables are there, 4C2 6 combinations I should get. AB, AC, AD, BC, BD and CD. These are nothing but A square plus B square plus C square plus D square. It is 64 minus 24, 40. That means I will not use these equation. I will use these equation right now. A square plus B square plus C square plus D square. It is nothing but 40. It is nothing but 40. Now see here. A plus B plus C plus D. It is 8. Next is A square plus B square plus C square plus D square. It is nothing but 40. What is he asking? Greatest possible value of 8. D, greatest possible value. So D is nothing but 8 minus of A plus B plus C. So D is maximum. That means ABC should be minimum. It is given real numbers, so we don't know. If it is given natural number, I would have substituted 1. So ABC, minimum value. Let me call it as X. Let me call it as X. X plus X plus X plus D. It is nothing but 8. 3X is nothing but 8 minus D. 3X plus D. It is nothing but 8. So these is nothing but D is nothing but 8 minus 3x. d is nothing but 8 minus 3x. So this equation is d square equivalent to 40 minus of x square plus x square plus x square. D is nothing but 8 minus 3x whole square equivalent to 40 minus 3x square. 40 minus 3x square. I hope it is clear, right? So from there you will get the value of x, substitute here, you will get the value of maximum d. I hope the idea it is clear. Or what you can do is 3x plus d, it is nothing but 8. D is nothing but, x is nothing but 8 minus d by 3. You can substitute in the equation, that also will give you directly the value of d. You do it in any way. This equation replace it with a square plus b square plus c square plus d square is 40. Next one. Recursive and iterative function, most commonly asked questions. F of n is nothing but 4n plus root of 4n square minus 1 divided by root of 2n plus 1 plus root of 2n minus 1. So you can write these 4n as root of 2n plus 1 whole square plus root of 2n minus 1 whole square. A square plus b square. This is nothing but root of 2n plus 1 into root of 2n minus 1 divided by 2n plus 1 plus root of 2n minus 1. If I multiply it with root of 2n plus 1 minus of root of 2n minus 1, this is root of 2n plus 1 minus of root of 2n minus 1. A minus b into a square plus b square plus ab. This is nothing but a cube minus b cube. A cube minus b cube. Denominator a square minus b square. This is nothing but 2. So this is nothing but root of 2n plus 1 whole cube minus of root of 2n minus 1 whole cube divided by 2. This is actually f of n value. It is actually f of n value. Now it is simple substitution, you will get the answer. Right? I hope the idea it is clear, right? This is root of 2n plus 1. Now if you see here, this is nothing but f of n is nothing but root of 2n plus 1 whole cube minus of root of 2n minus 1 whole cube divided by 2. F of 1 is nothing but f of 1 is root 3 whole cube minus root 1 whole cube divided by 2. F of 2 is nothing but root of 5 whole cube minus root 3 whole cube divided by 2, and so on up to f of 40 is nothing but root of 81 cube minus of root of 71 cube divided by 2. All intermediate values will be cancelled. Calculate it and you will find the answer. I hope the idea it is clear. Simple final step, add and you will get the answer. Right? Very, very good question it is, sir. Right? Next 3 questions are very, very good questions. X equivalent to plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4 till plus or minus 10. How many distinct values, how many possible values x will take? If I want x maximum value, x is plus 1, plus 2, plus 3 and so on up to plus 10. This is nothing but summation 10. N into n plus 1 by 2, which is nothing but 55. Maximum value x can take is plus 55. If it is minimum, x is minus 1, minus 2, minus 3 till minus 10. This is nothing but minus summation 10, which is minus 55. Now the question is whether all the values we will get or any other values will be omitted. So x value oscillates between minus 55 and 55. X value oscillates between minus 55 and 55. Concept. Suppose if it is plus 1 plus 2 plus 3, the sum is nothing but 6. Sum is nothing but 6. Let me replace plus 2 with minus 2. Plus 2 with minus 2. 4 minus 2, the sum is nothing but 2. If you observe closely, these nothing but the same sum where all are positive minus 2 became minus 2. So the drop is 2 into the number whose sign is changed. Am I right? Number whose sign is changed. Obviously 2 became minus 2 means drop is minus 4 only, right? Or if these nothing but total sum, these nothing but total sum minus 2 into sum of all the numbers whose signs are changed. Sum of all the numbers whose signs are changed. Total sum minus 2 into sum of all the numbers whose signs are changed. So the total sum is nothing but 55 minus 2 into some value p. 2 into any number even. 55, it is an odd number. Odd minus even is odd. That means what are the values x will take? X will take all in odd integral values. X will take all odd integral values from minus 55 to 55. X will take all the odd integral values from minus 55 to 55. Very, very good question it is, sir. If x maximum we want means all are plus. So summation 10 is 55. X is minimum means all are minus, which is minus 55. Minus 55 to 55, the value oscillates. If the sign is changed, if 2 is becoming minus 2, the net effect will be double the value whose sign is changed. If 3 is becoming minus 3, the drop is minus 6 only, right? If 4 is becoming minus 4, the drop is minus 8 only, right? So 2 is becoming minus 2, the drop is 2 into the number whose signs are changed. If more than one number signs are changed, add all the numbers and put it as 2 into. This value I am calling it as p. 55 is an odd number. 2 into any number, even number. Odd minus even is odd. Answer is all the odd integral values from minus 55 to 55. Minus 55 to minus 1, 55. 0 to 55, 56. Total 111 values, odd integral will be 56. Answer for this question is nothing but 56. Answer question is nothing but 56. I hope the idea it is clear. If a number sign is changed and it is getting added, the net change will be 2 into that number with a minus sign before. That is the learning from this question. Next one, it is ending with 11. So it is x is plus 1 plus 2 till plus 11. X maximum, which is summation 11, which is 66. X minimum minus summation 11, which is minus 66. Minus 66 to 66. So what will be the total possible values? Total possible value is total sum possible, total sum, right, best case, minus 2 into the numbers, sum of all the numbers whose sign is changed. Sum of all the numbers whose sign is changed. Total sum is 11 into 12 by 2 minus 2 into any number even. These also even. Even minus even. Answer is even. So all even integral values. All even integral values. 67 will be the answer. Starting and ending both are even. I hope the idea it is clear. I hope the idea it is clear. So if the signs are changed, the net effect will be 2 into the number whose signs are changed. I hope the idea is very clear to you. 11 into 12 by 2 minus 2 into any number even. Let me create one more question so that it will be very clear to you. Question is, by changing the sign of how many numbers? By changing the sign of how many numbers? By changing the sign of how many natural numbers will the sum of 2005 natural numbers, will the sum of 2005 natural numbers becomes 2006? Beautiful question, sir. By changing the sign of how many natural numbers will the sum of 2005 natural numbers becomes 2006? 1, 2, 3 till 2005. Sum is nothing but 2005 into 2006 by 2. These 1003. Odd into odd is odd. So answer is nothing but odd number minus, if the sign is changed, 2 into sum of all the numbers whose signs are changed. Sum of all the numbers whose signs are changed. This is odd. 2 into any number is even. Odd minus even is odd. I will only get the answer odd, but this answer is asking even. So answer is not possible. In any case, you will not get the sum as 2006. In any case, you will not get the sum as 2006. I hope the idea is crystal clear to you.